This will be a colorful experiment. First though, here's some chromium trioxide. The foil boat contained ethanol. It's a powerful oxidizing agent, so be careful. First we start by weighing out two 20-gram portions of potassium dichromate. Put one of them in a larger beaker capable of holding at least 200 ml. To the larger beaker, add a magnetic stir bar, and then try to dissolve the solid in 80 ml of warm water with stirring. Some will remain undissolved, but this is okay. As it dissolves, the dichromate will cool the solution. For reference, here's the temperature when saturated. Measure out 40 ml of concentrated sulfuric acid. Then slowly and carefully add the acid to the stirred solution. A lot of heat will be given out, so go slow and take care, especially in the beginning. You'll quickly see the remainder of the solid dissolve, and the solution will turn a darker red color. This is chromic acid, effectively hydrated chromium trioxide, forming in solution. The temperature will go up considerably, so pause if you need to during the addition. The last part of the acid is easier to add, with less of an exotherm. Temperature after complete addition is around 100 degrees. The mixture will boil around 120. Now add the other 20 grams of dichromate to the solution and dissolve with stirring. The mixture should cool slightly, and now finally we add, slowly and carefully, a further 40 ml of concentrated sulfuric acid. The color of the solution darkens to begin with, and then during the final part of the addition you will start to see a precipitate forming and crystals spinning in the solution. This is our chromium trioxide precipitating from the solution due to the dehydrating power of the sulfuric acid, sucking water away from the chromic acid. The crystals will grow as the solution cools, so now, cool it down to around 20 degrees. You should end up with quite a lot of crystals, like this. Set up for vacuum filtration. This time, you must use a glass sinter to filter, as a paper filter will immediately oxidize and burn. Allow the crystals to become damp, but don't dry for too long or they will absorb moisture from the atmosphere. Around 65 grams of damp crystals. They are impure with acid, and probably sulfate salt crystals too, but they will work fine for our next step. Add 50 ml of concentrated hydrochloric acid to 50 ml of water in a beaker. With stirring, add the crude chromium trioxide obtained in the last step. It will dissolve to create an orange solution like this, which contains the chlorochromic acid species. Next, measure out 20 ml of pyridine. Add this to the stirred chlorochromic acid solution. You will notice a slight temperature increase, and then after cooling slightly, bright orange crystals will begin to form in solution. Cool the solution to 20 degrees, and then vacuum filter. You can keep the pump running until the crystals are quite dry. Here's our product, pyridinium chlorochromate as beautiful orange crystals. I didn't calculate the yield for this batch, but you can expect to obtain around 35 grams of product from one batch, which is a 70% yield on the original dichromate starting material. A note on disposal: since chromium-6 compounds are carcinogenic, dilute the washings and add isopropanol to reduce them down. Before disposal, the solution may get warm, so take care. No more orange-yellow color means you're good. Pyridinium chlorochromate is a useful reagent for selectively oxidizing primary alcohols to aldehydes without going all the way to the carboxylic acid. Just make sure you use the right conditions and solvent, and keep water out of the reaction.